Kirkman. And we're back. We're looking at 8.2, the vertex form of a quadratic function. You're in your student companion on page 172 and 173. So we're going to break down this vertex form of the quadratic function a little bit more. And this first example is going to have you focus on the letter K in this form. And later in the lesson, you're going to see the whole vertex form and we'll put it all together. But here we're just going to look at K. So the function g of x, which equals x squared minus 4, we're comparing this to our parent function again, okay? So we're going to take a look. Our parent function is in blue, and then our new function, g, is in orange here. And we want to look and compare what is happening to the parabola. What is k doing to our parabola? So what you can probably tell is that the two graphs have the same axis of symmetry, 0, okay? And that each of these points are directly translated vertically down 4 units, okay? So our function f, the point here is the same x value in each of these functions. And then if I go down 4, I get my new function here, okay? The vertex of the graph went from 0, 0 to 0, negative 4. Therefore, we can write down the assumption that the letter K translates our parabola vertically. Okay, it's going to go up or down. It does not, the value k does not affect the line of symmetry. So we have 2 examples here. So we're going to do the first one together, and then I want you to do the second one on your own. I want you to explain to me, how does the graph of h of x equals x squared plus 3 compare to its parent function? Okay, so again, we're just looking at this k right here. And because we know that it translates it vertically and it's a plus 3, that means that this new graph is going to translate up 3 units. Okay, so h of x, whoopsie, is going to translate up to 3 units. Right there. Okay, let's check our answer. Shifted up 3 units. We know the axis of symmetry is the same. Beautiful. So go ahead and do B on your own. All right, example 2 is now looking at another part of our vertex form of a quadratic equation, and we're looking at the letter H. Now, we've seen this in our warm-up a lot, so you guys kind of have an idea about H and K, but this is going to just solidify this here. So we have our graph, g of x is equal to the quantity x minus 3 squared, and we're going to compare that to our parent function. So same thing, we have our parent function here in orange, and our new graph, g of x, is here in blue. When I subtract 3 from the x and all of this is being squared, so notice that the difference between the k and the h is that the k is being added or subtracted outside of this square right here, whereas h is inside, it's included in the square. Okay, but anyways, when I deal with the letter h, it is translating my parabola horizontally, okay? My axis of symmetry is also translated horizontally. The vertex is translated horizontally, and then every point is also translated horizontally. So you can write this down in your notes that the letter H translates our parabola horizontally. And then they do it a little bit differently here, but we know from our warm-up that it is really the opposite of h. So if h is being subtracted, we're going to move to the right. If h is being added, we're going to move to the left. Whoopsie, if I can write. So just remember that we're kind of taking the opposite of the h that's within this parenthesis. So let's take a look at some examples. So we'll do the first one together and you'll do the next one. So I want to know how this is being translated. And again, I am going to use my information here. It's going to be the opposite of what's happening here. So because this H is being added, I am going to end up translating 1 unit to the right, or sorry, to the left, because I'm going the opposite direction. So instead of going to the right, I'm going left. That means that my line of symmetry is moving 1 unit left and my vertex is moving 1 unit left. Oops. And so let's check our answer here. The vertex and axis of symmetry are shifted 1 unit left. So go ahead and try B on your own. All right, so now we're starting to put all of this together. We have our vertex form of our equation, all of it at the top, ax minus h squared plus k. And we're going to start putting all the pieces together. So here they, again, take it baby steps. We're not going to pay attention to a. We're going to say a is just 1. What's going on when I have both h and k together? Well, as I move h, my vertex goes horizontally. As I move k, my vertex goes vertically. Notice that here, when they're looking at h, they're not including the sign. And that's where I said what we learned and talked about in class is a little different than what they do in the textbook, but both of us are right. They are kind of ignoring the sign and taking h on its own. And they'll show later how when it's a positive, it's really a minus, a negative. But for us, I think it's easier to just think h is the opposite of whatever the sign is there. Okay. But as we move, I can move horizontally and vertically as I move my h and change h and k. Okay. So to look at it again now, including a, we now have 3 variables that we are changing. A, if you remember, is going to stretch or shrink or flip my parabola, facing up, facing down, shrinking, or widening. H is going to move side to side, and K is going to move up or down, okay? All of these things are going to change. So this is where I'm going to go ahead and pull up some of our information. You're going to take some notes about how all of these things react together. All right, these are the notes I would write down. We should memorize that the vertex of our coordinate is always going to be the opposite of h and k. The axis of symmetry is going to equal h. Our line at x is going to be whatever h is. Or I'm sorry, it should be the opposite of h. That is wrong. It should be the opposite of h. I have to fix that here. Let's see. There we go. Okay. The opposite of h moves the vertex horizontally, side to side. K moves the vertex vertically, up and down. The absolute value of a, if it's greater than 0, stretches or makes my parabola narrower. The absolute value of a, or less than 0, compresses or makes it wider. If a is positive, we open down, and if a is negative, we open down, and if a is positive, we open up. All of this whole equation right here is the vertex form of a quadratic function. So pause for a second, make sure you have all of this down. These are the things we need to memorize, and this will help you graph it a lot easier because you can look at the information given and you can tell where it's going compared to the parent function. It will also help you describe its relationship to the parent function a lot easier if you have these kind of key points written down. Okay, so now that you have those facts written down, we're going to compare this new function here to the parent function in vertex form. And you're going to basically answer these questions about what's going on, okay? So with this new formula, where is the vertex at? Write that down. With this formula, where is the axis of symmetry? How many units is this function going to move horizontally? How much? What direction? How much is this going to move vertically? In what direction? Will this be narrower or wider than the parent function? And will it open up or down? Okay, now in example 4, we're going to start graphing this. Now you can use the key information that we had to kind of translate from the parent function, but if you want to know just straight steps on graphing, this is what we are going to do. So we're going to graph this function right here, -2 times the quantity x plus 1 squared plus 5. Okay, the first thing that we are going to do is plot the vertex, and we know that it's the vertex because we're doing the opposite of h. Okay, my vertex is the opposite of h, which was a +1, so -1, and k is 5. So my vertex is at -1, 5. Now we're going to evaluate the function to find 2 other points. So I'm going to plug it into my equation. So I'm going to say, okay, what if we're just move over, right? Because my vertex is at -1, what if x is 0? Okay, I would do -2 times 0 plus 1 squared plus 5. Okay, so -2 times 1 squared plus 5. -2 times 1 is just -2 plus 5 is -3. Oh, sorry, +3. That is how they got this point right here, was they took a value for x, they plugged it into the equation, and then they got their coordinate, their ordered pair. Okay, they do it again for +1. So over here, I'm going to say, okay, what if x is +1? And you can pick these numbers. You want to pick numbers that are on the same side of your vertex. Okay, so pick right or left. And I would just pick the next 2 numbers, right, on x. So because our vertex was at -1, I'm going to pick the numbers 0 and 1. Okay, so over here, we're going to say, okay, well, what if it's +1? So I'm going to say that's going to be 1 plus 1 squared plus 5, -2 times 2 squared plus 5, -2 times 4 plus 5, -8 plus 5. That's how we get -3. And that's how they got their second dot right here, 1, -3. Okay, so we plotted the vertex here, and then we evaluated the function for 2 points. We are now going to reflect equal distance across the x-axis, or the axis of symmetry. We're going to reflect my points over there, okay? So this one here was 1 away from my line of symmetry, so I'm going to go 1 away on the left. Here, I'm 2 away from my line of symmetry, so my points are now 2 away. I'm now going to draw a parabola through those points, and boom, I have made a graph. All right, so let's graph another one together in your book. So here's my function. The first thing I'm going to do is graph the vertex. So that's going to be +2, 1. So I'm going to take one of these points, and I'm going to go +2 and 1. That's my vertex. I am now going to solve my other 2 points, okay? So I'm going to do that really quickly because we're running out of time. Okay, so over here I said, all right, my vertex is here as 2. So I'm going to go 1 more and say, what if x is 3? I plugged that into my equation here, and I said x is 3, and I solved, and I got this point right here, 3, -2. So I'm going to take one of my dots here, and I'm going to put it at 3, -2. Now, it wants you, when you're doing this on paper, you want to do a second dot. So over here, I did one at 4, but as you can tell, my point down here ends up becoming 4, -13. So my other point would be way down off the chart right here. But you would plot that if you were doing this on paper, okay? And then you're going to reflect across. So because this is my vertex here, I want to go directly across from this point by 1 square. So this dot is going to match up right here, okay? Directly across my line of symmetry here, my axis of symmetry on the left-hand side. And then if I check my answer, you can see there's my answer. So my vertex was correct. It was 2, 1. And then we had 4, -11. Oh, that's because I did my math wrong. If you look over here, -12 plus 1 is -11. But there's my other point that's correct. And then that point that's reflected across was 1, -2. So if you look here, 1, -2. Okay, so go ahead and try graphing on your own with this function right here, and we'll go over it in class. Okay, we are not going to do example 5, so just make sure that you've done all of your examples up through 4. Make sure you have your notes written down, and we'll see you in class.